Hi everyone, very good evening to all of you. So guys, all of you are present and receiving my transmission without any interruptions. Can you please confirm it and say something? Can you please reply any greeting message which can make me happy, or something funny, a joke or something? Good evening Jia, good evening Shillong. Okay guys, so Shillong is there. Shillong, can you please wave? Can you please wave towards the camera? Shillong Center. Okay, got it. Thank you. I guess Jia is there. Alright. So guys, where did we left off in the previous class? Oh, thank you Jia. Thank you. So, where did we left off in the previous class? We were talking about the combined motion of multiple blocks. Alright, so suppose if we have blocks stacked over each other, then how friction acts and how the body moves in those cases. So I explained you the basic principle. You first have to assume, first of all you have to check whether the bodies will move or not, because maybe the force of friction is large enough to to take over the external force. So in that case the body will not move. If the friction is not sufficient and the motion will be there, then you have to assume, at first you have to assume both the blocks or all the blocks are moving together. Find the common acceleration. Using this common acceleration, see what would be the required friction on the upper block, alright, where force is not applied. You will understand every step. Now let me first repeat it. So assume all the blocks are moving together, find their common acceleration. Using that common acceleration, see how much friction is required and whether this friction lies within the limit of limiting friction or not. If they lie in the limiting friction, then your assumption is correct and the bodies are moving with the same acceleration. If not, then the accelerations would be different. Okay, and if they are moving, then obviously you have to apply the maximum force. So we will consider all the cases, and for the half of around for half an hour we will do these questions. Then in the remaining 1 hour we will do the kinematics part of circular motion. Okay, good evening Okrul, good evening. So okay, the first question, question number 1 is, suppose I have two blocks this is 5 kilogram, this is 10 kilogram, and the force is applied on the upper block. The force of 50 Newton is applied on the upper block. Okay, the coefficient of friction here is 0.4 and the lowermost surface is smooth. Okay, this is smooth. So you have to find the accelerations of the block. In all the questions you would have to do the same thing. Calculate the accelerations. Calculate the accelerations of the block. Calculate the accelerations of blocks and force of friction between them. Now first step is whether the blocks will move or not. Obviously they will move because the lowermost surface is smooth. If it is smooth and if you apply some force, it will definitely move. Alright, so movement is there. Now the first step is find the common acceleration. Your step 1 is find the common acceleration AC. Tell me, what is the answer? assume that they are a single block, okay, and the force acting on it is how much? 15 Newton. The combined mass is 5 plus 10, 15 kilogram. So find the common acceleration. What is the common acceleration? The common acceleration is net force 50 divided by total mass. It is 10 by 3 meter per second square. Okay, 10 by 3 meter per second square, which is 3.33. Very good, Jia. Okay, now once we have calculated the common acceleration, we have to check whether friction can support this acceleration or not. Okay, so check. Now find the force of friction required. Okay. So if you talk about this 5 kilogram force, all right, 5 kilogram block. So look at the 5 kilogram block. This is the 5 kilogram block, and look at the forces on it. It has weight 50. It has normal force in the upward direction, and friction will be in the backward direction, obviously. And we have just calculated the acceleration of this block. Because it is the part of the combined body, its acceleration will be this only, 10 by 3 meter per second square. 10 by 3 meter per second square. Okay. Now what we have to do, we have to check whether can we have this acceleration or not. I forgot this external force of 50 Newton. External force of 50. So guys, first of all, apply the Newton laws of motion. Yeah, before we do that, the first law of motion says that n is equals to 50. I think there is no doubt in this, because in the vertical direction the block is not moving, so forces must be same. N is equals to 50. Now look at the forces in the horizontal direction. So 50 minus F is equals to 10 by 3. So F 10 by 3 into 5. So F is equals to 50 plus 50 by 50 minus 50 by 3. It is equals to 100 by 3. Okay, 100 by 3 is how much? It will be equals to 33.3 Newton. 33.3 Newton. This is the required friction. All right, this is the required friction. Now look at the friction force which is available here. All right, the maximum friction. The maximum friction is equals to mu into n. The limiting friction is mu into n. Mu is how much? Mu is 0.4. 0.4. 0.4 into n. N is 50. So it is equals to 20 Newton. Now see, your assumption is wrong. How come? The limiting friction is 20 Newton only, and for the combined moment we need 33.33 Newton. It means we cannot have this motion. Friction cannot support this motion. So I will say our assumption is wrong. Bodies are moving independently, or you can say separately. Is it clear what we have done? Using the common acceleration, we calculated what would be the required friction for that acceleration. We came to know that it must be 33.33 Newton. And then we calculated the limiting friction, the maximum friction value which is available. It is mu into n, so 20 Newton. Clearly 20 Newton is less than 33.33. The limiting friction must be more, all right. Your friction must be within the limits of limiting friction. It means our assumption is wrong. The bodies are not moving, the bodies are not moving as a whole, as a single unit. They are moving separately. Now what is this step clear to all of you? First tell me. Thank you Jia for answering. Okhrul and Shillong, can you please tell me what whether you have understood this part or not? Yep, okay, very good. So now one thing is sure, the bodies are moving separately. It means there is a relative motion. It means there is a relative motion between the two blocks. There is a relative motion between the two blocks, okay, while the force was applied on the upper block. How much? 50. Okay. Now we know that there must be a relative motion, they are not moving together. If that is the case, then if you look at the free body diagram, then 50 has one forward force, this much, 5 kilograms, sorry, not 50. The 5 kilogram block has one forward force of 50 Newton, and in the backward the friction will be limiting friction, because there is a relative motion between the two surfaces. Whenever we have a relative motion between two surfaces, maximum friction acts. It is mu into n. Alright. So n is equals to how much? N is equals to 50 Newton. Alright. And the acceleration will be in the forward direction. So let's calculate the acceleration. So 50 minus mu into n, which is the maximum friction, isn't it? This is the maximum friction. Wait a minute. Okay, whatever. So 50 minus mu n is equals to 5 into a. So 50 minus 0.4 into 50 is equals to 5 into a. 50 minus 20 is equals to 5 into a is equals to 30 by 5, which is 6 meter per second square. This is the acceleration of the upper block. Okay, this is the acceleration of the 5 kilogram block. पे पटा दीजिए रियाज जी, रियाज. Acceleration is 6 meter per second square. Okay, this is for the upper block. Now, if this much friction is acting on the upper block, then from Newton's third law of motion, the 10 kilogram block, if we talk about the 10 kilogram block, it will have equal and opposite friction. So the force acting on the lower block will be how much? Mu into n. Okay, remember, on the upper block, if the friction is acting in the backward direction, then on the lower block friction will act in the forward direction. Okay, makes sense? So if you talk about the 10 kilogram block, the 10 kilogram block, the 10 kilogram block has a forward force of mu into n, which is 20 Newton. Alright, I am directly writing it. So acceleration is 20 by 10, which is the mass, 2 meter per second square. Is this whole question clear or not? Shillong Center, Ukhrul. Pakka? Can we do another question on this? So we have calculated everything which we needed. Pakka? Alright. So let's do another question. The question is, we have two blocks, mass of A is 10, this is 10 kilogram, this is 15 kilogram, okay, and some force F is acting on the upper block. The coefficient of friction is 0.5 here, and with ground the friction is 0, it is smooth. Okay. The question is, find the maximum value of F such that both the blocks move together. Both the blocks move together. See, what was the problem? When they were moving together, in the previous question we learned, when they were moving together, the friction which was required for the combined movement, the friction was less needed to have the, to have the same acceleration in the blocks. So if we reduce our force, then we can have an acceleration low enough which can be supported by friction. All right, low external force can produce an acceleration low enough which can be supported by acceleration. Simple, it's a very simple question. No need to stress. Load नहीं लेने का. I hope you understand the meaning of load नहीं लेने का, tension नहीं लेने का. When I'll show you the solution now, you'll see, oh, it was that easy. Should I tell you the answer? Okay, let me tell you the steps. The steps are step 1 of Mongolia. Ha, ha, ha. It was a joke, you wouldn't understand. Step 1. So step 1 is find the common acceleration. Find AC, common acceleration. Step 2 is find friction F for 10 kgs acceleration AC. Basically, what is the meaning of this? Find the required friction for the upper block to have this acceleration. Step 3, the required friction F is equals to mu into n. Khatam. The end. Tada. This is the end. Do this, you'll get the answer. Okay, so let me explain the solution. So I am removing this. So first step is find the common acceleration. We have to find the common acceleration. Obviously, this will be in terms of f. So common acceleration AC is equals to capital F by combined mass. This is 25. This is the common acceleration. Now I told you, find the required friction on the upper block if you have this acceleration. How much? AC. So can I write capital F minus small f is equals to mass of the block into acceleration, okay, AC. So capital F minus small f is 10 f by 25, which makes capital F, not capital F, which makes small f equals to capital F minus 10 by 25, which is 2 by 5 capital F. So it will be 3 by 5 f. Is that clear? The required friction will be 3f by 5. Okay. Now they are talking about the maximum external force. It means in that case we will have the maximum friction. Okay. So maximum friction is equals to how much? Mu into n. So force is 3f by 5 is equals to mu is how much? 0.25, I guess, 0.25 into n is equals to mg, which is 100. Okay. So F is equals to 25 into 5 by 3, 125 by 3 Newton. This is the answer. No, I'll do this. This is much better. Is this question clear to each and every one of you? Is this question just, these are very few simple steps, just follow these and you will get the answer, no problem. Understood, all of you? Can we proceed to a next question similar to this? All right, we will do another 2 questions on this and then we can proceed to uniform circular motion. Okay, the question is, we have 2 blocks of 10 and 20 masses. This capital F is 90 Newton, this is A, this is B. It is given that mass of A is 10 kilogram, mass of B is equals to 20 kilogram. Okay, mass of A is 10, mass of B is 20, and this is 0.4 and this is smooth. Okay, again find the accelerations of the block, find acceleration of A, find acceleration of B, and the force of friction. So calculate these values. Okay, you must do this one, yaar. This is really easy. We'll do another question on this and then we can proceed to next topic. The topic is circular motion. Wrong answer, Jia, wrong answer. Shillong, what's yours? Okay, one more minute, and then I'll explain. Okay, Shillong, your answer is also wrong. See, it's a very simple thing. First of all, find the common acceleration. Assuming they are moving together, first, that is your first step, alright. So, force is 90, alright. So, 90 divided by 10 plus 20, 30. So, acceleration is 3 meter per second square. This is the common acceleration, assuming they will both move together. Once we have calculated the common acceleration, we have to check whether the friction can support this value or not. Okay. So 3 meter per second square. Alright. So look at the upper block A. Block A has friction acting in the forward direction. Alright. On A, friction will act in the forward direction because it is the lower block which is trying to move. So the force B will apply on A will be in the forward direction. Alright, on B it will be in the backward direction. So on A it will be in the forward direction, and it must produce an acceleration of how much? 3 meter per second square. So F is equals to MA. From this, F is equals to 10 into 3, F is 30 Newton. So for this, we would need 30 Newton of force. Alright, we would need 30 Newton of force. Now let's talk about what is the maximum friction available. What is F max? F max is mu into N. Mu is 0.4, isn't it? That was 0.4. Mass was, N is mg, no? So it is 10 into 10. So it is equals to 40 Newton. Maximum friction is 40 Newton. The required friction is 30 Newton. It means if F is less than or equals to F max, then our assumption is correct. Assumption seems to be correct, because we have to check on the lower block also, but we can say assumption seems to be correct, because the upper block follows this. Now look at the lower block. If you talk about the lower block B, on the lower block we have a force of 90 Newton in the forward direction, and this friction, this 30 Newton, will act in the backward direction, 30 Newton. Okay, and the mass of B was 20 kilogram. Alright, so let's calculate the acceleration. The acceleration is 90 minus 30 divided by 20. So 60 by 20, 3 meter per second square. So yes, indeed, both the blocks confirm this, that the friction will be 30 Newton and the common acceleration will be 3 meter per second square. Solved. Problem is solved. Have I moved too quick? Should I slow down and explain you once more? Please let me know. Is it clear to all of you? So both the blocks will move together with 3 meter per second square of acceleration, and the friction will be 30 Newton. Yep, okay. Last question on this, guys, last question. Please give all you got for this question, alright? So we again have two blocks. This is A, this is B. So mass of A is equals to 10 kilograms. Mass of B is 15 kilograms. And F is equals to 10 Newton. Okay. Again the question is, find the common acceleration and friction force. Find acceleration of A, acceleration of B, and friction. Yeah, by the way, F is on the lower block. F is on the lower block. Oh, wait a minute. F is 90, yaar. F is 90. Sorry. The force is 90 Newton. I did not give it. Yaar, how can you solve? I'm stupid. The coefficient of friction here mu1 is 0.4 and mu2 is equals to 0.2. That is the complete question. I'm sorry, I forget few things. Acceleration of A is 0.25 and B is 3 meter per second square. Okay guys, now in this question, first of all, you have to see whether the blocks will move or not, because it is possible that they will not move at all. Acceleration will be 0, because see, on the lower block, since it is rough now, there will be a force of friction on B, let's call that FB. Okay. Now this FB might be large enough to stop this F, alright, to overcome this F. So we have to see what is the maximum value, alright. So we need to calculate the limiting friction of FB. So FB max is equals to the normal force here. So if we have to combine the single body, its mass will be 10 plus 25, okay. So the normal force here, I am writing it directly. the normal force here will be equals to 250. So mu is 0.2 into 250. All right. Don't ask me why the normal force here is 250, because just do it. All right, you will see. Or simply you can assume it is a single body. It is a single body. Its mass will be 10 plus 15, 25, and into 10 it will be 250. Okay. So it is equals to 50 Newton. All right. So if you look at the external force is 90 Newton, which is large enough the maximum friction available. It proves that motion will be there, because we have the motion will be there. Motion will happen. If the motion is there, then we have to assume, we have to assume to the next part. All right, we have to assume that both the blocks are moving together. So let's find the common acceleration. Assuming that the blocks will move together. Assuming the blocks to be moving together, we have how much? 10 plus 15. So 25 kilogram of block, 90 Newton in the backward direction, and obviously the friction will act here. You might have forgotten that in this case the friction will be there, and the friction will be its maximum value, which is how much? 50. So find the acceleration. Acceleration is 90 minus 50 by 25, which is 40 by 25, which is 8 by 5, 0.8 meter per second square. Make sense? 0.8 or how much? Oh, sorry. It will be 1 point, how much? 40 by 25 is how much? 8 by 5, 1.6 meter per second square. This is the acceleration. All right. Understood? This is the common accelerations of the block. This is the common acceleration of the block. Once we have calculated the common acceleration, now you have to go to the next step. You have to see whether A can have sufficient friction or not. Clear? Shillong Center, yes or no? If it is clear, raise your hand. If it is not clear, don't raise your hands. Shillong, is this part clear or not? Pakka? That's a very confused hand, and the other students are not raising. Okay. It's not clear. Bhai, in this case, the friction will act on the lower surface as well, na? And if they are accelerating, if they are moving, then maximum friction will act. Isn't it? So in the first step, see, this first step was to check whether the motion will be there or not, because this friction could be large enough to stop the motion. But we checked it is not. 50 Newton is less than 90 Newton, so motion will be there. That is confirmed. Now let's talk about this. By acceleration is 1.6 meter per second square. All right. Now look at the upper block A. So if you talk about the upper block A, it must have an acceleration of 1.6 meter per second square. Its mass is 10 kilogram, and there will be only one force acting on it, and that is friction. All right. This friction is equals to 10 into 1.6, which is 16 Newton, and it should be less than the limiting friction. So let's check limiting friction. Limiting friction is mu into mass of A into G, mu into N. It is 0.4 into 100, which is 40 Newton. Now as you can see, the 40 Newton is big enough, all right, because we only need 16, so it will very happily provide 16 Newton. And since F is less than or equals to limiting friction, our assumption is correct. Our assumption is correct, that the blocks will move together and they will have an acceleration of 1.6 meter per second square. Yeah? Understood? Okay. Now I hope these types of questions are clear to you, and I can give you one homework as well, but let's proceed and start doing the next topic. Okay, so let's talk about the uniform circular motion. The uniform circular motion. Okay. So first of all, let's talk about very few elementary things. I hope you know the relation between angle in radians theta and the arc length. Suppose this arc length is L and the radius is R, alright. So can you please tell me the relation between these three quantities, arc length and theta and radius? Isn't it arc length into radius is equals, radius into angle is equals to arc length? This is the relation. R into theta is equals to L. Isn't it? Now keep this information with you, it's going to be useful. Now let me talk about the circular motion. Okay. Let me talk about the circular motion. Suppose there is a circle and a body is moving along this path. Okay, a body is moving, suppose the body is here and it is moving like this. All right, it is moving like this. Now it is moving about a point which is the center O. Okay, it is moving about a point which is center O. Now, how this motion is different from your ordinary kinematic, your ordinary rectilinear motion? All right. Remember, there is two types of motion in kinematics: rectilinear, or maybe I should say straight line motion, and a curvilinear motion. All right. This is the curvilinear motion. It is along the curve. It is not in the straight line. So, how it is different? In a straight line motion, we determine the position of the object with respect to a reference body in terms of distances. All right. We call it displacement. But here, since the distance between the point and the object is same, it is always r. Alright, it is always r. Since the distance is same, describing the position of an object in terms of displacement is not correct. Alright, it is not at all good. We have to adopt different methodology to indicate or to define its displacement. And we define it in a very, very simple way. All right, and you can also do that. Suppose the object was here initially. This is the initial position. This is the initial position, and then the object reach this point. Let's call that B. Let's call that is the final position. Okay, this is the final position. Now, what changed? What is the quantity that changed? That quantity, my dear friends, is this theta. Okay, we describe the circular motion not in terms of displacement normally, but in terms of angular displacement theta. This theta is known as angular displacement. All right, it is the angular displacement. It is the angular displacement. If we talk about the angular speed, so just like in the rectilinear motion, remember the speed was what? What is the velocity? Velocity was displacement upon time. In a similar way, angular velocity angular velocity is the rate of change of angular displacement, the rate of change of angular displacement. Okay, the rate of change of angular displacement. So can I write your angular velocity as d theta by dt, and to distinguish between normal velocity and angular velocity we use omega. Okay, omega as a symbol of angular velocity. Is it clear, guys? Angular velocity has a symbol of omega and it is d theta by dt. It is very same. All right, focus here what I am writing in the green color. In the linear motion, x was displacement, isn't it? X was displacement. And what was the velocity? Velocity was dx by dt. The only difference here is that instead of x, we have displacement in terms of angle, angular displacement. And just like your motion in the straight line, velocity is defined as rate of change of displacement. Angular velocity is the rate of change of angular displacement. So d theta by dt. Okay, all right. Then in the similar way we can define alpha. What is alpha? Alpha is angular acceleration. It is d omega by dt. Done? All right. So let me tell you the correlation between the angular motion and the translational motion. All right, this is translational motion. I should not say translational because that is also translational. Let me say motion in a straight line. All right, or rectilinear motion. Rectilinear motion. This is the curvilinear motion. Spelling might be incorrect, please check, or simply the circular motion. All right, because as of now just circular motion, curvilinear or circular motion. All right, in the rectilinear motion, what is displacement? Displacement was x. Here it is angular displacement, and it is in theta. All right, and remember this theta to be in radians. Remember this is in radians always. Okay, velocity is dx by dt, then angular velocity will be omega, which is d theta by dt. Acceleration is dv by dt, which is equals to d square x by dt square. Alpha is equals to d omega by dt, or you can say d square theta by dt square. This is the angular acceleration. If they have the relation, if they have the correlation, so does the equations of motion. Remember the three equations of motion? The three equations of motion were v is equals to u plus at. In the same way we have omega is equals to omega naught plus alpha t. Okay, where omega naught is the initial angular velocity, omega is the final angular velocity, alpha is angular acceleration. V square minus u square is equals to 2as. Here it is omega square minus omega naught square is equals to 2 alpha. What is displacement? Theta. And finally, the last one is S is equals to ut plus half at square. Here it is theta, which is the displacement, is equals to omega naught t plus half alpha t square. Everything is same, everything. Just remember, the displacement is, I can just write the final summary here. Displacement is theta, velocity is omega, initial velocity is omega naught, v is omega, u is omega naught, acceleration is alpha. That's it. Just replace these things and you'll get your equation. Now, if we okay, first write down the equations, then I'll discuss another thing. If you have copied, please let me know. Okay. So, if you go back, if we talk about the unit, displacement is measured in meters. Okay, it is measured in meters, while the angular displacement is measured in radians. If velocity is measured in meter per second, then angular velocity will be measured in radian per second. And acceleration is meter per second square. This will be radian per second square. Okay, so the units have the similar relation. If it is in meter per second, this will be in radian per second. Okay, so let's do few questions. Let me ask you the first question. The first question is, suppose there is a circular track. Okay, I start from this point. And initially I was at rest at t equals to 0, omega naught was 0. I start pedaling so that my angular acceleration is 4 radian per second square. Okay. Question is, find the number of revolutions. If or you can say, find the number of revolutions in 3 minutes. Okay, given that radius r, radius is equals to 15 meters. Understood the question? But that is not at all required. Angular acceleration is 4 radian per second square. Find the number of revolutions made in 3 minutes. A very simple, straightforward question. R is given to confuse you. Should I explain or can you do it? By see, first of all calculate theta. How much theta will be covered? It is equals to omega naught t plus half alpha t square. Okay, so theta, the total angle covered, is equals to 0 plus half alpha is 4 t square. Now t is what? 3 minutes. 3 minutes is 180 seconds. Okay, find this. Theta is equals to, this is 2 into 180 square. So let me use the calculator. 180 into 2. 64800 radians. Okay, 64800 radians. That is the total angular displacement. Alright. So guys, we all know that in one revolution, the angle covered is 2 pi radians, isn't it? Alright. And what is pi? Pi is 3.14. So around 6.28. In every revolution, we cover around 6.28 radians. So the number of revolutions, the number of revs is equals to total theta covered divided by 2 pi. Alright, remember this formula. Number of revolutions is total theta covered divided by 2 pi. Total theta is 64800. It is equals to 6.28. So let me tell you the answer. 6.28. So it is 10318.47 revs. Okay, this much or these many revolutions will be made. Is this question clear to all of you? Can I give you another? If you have any doubt, please let me know. Just go with the basics. Alright, just apply everything which we have learned in kinematics. Pakka clear? Alright. So let me ask you a few questions. Question is, a car covers 7.5 revolutions of a park in, let's say, 18 seconds. Okay, that's very, very fast. A car covers, I am giving you random data, so answer might have decimals. Alright, so please excuse that. A car covers 7.5 revolutions of a park in 18 seconds, assuming initially the angular velocity of the car was 1 radian, no, 2 radian per second. Okay, 2 radian per second. Find the acceleration alpha. That is the question. Find the angular acceleration alpha. Guys, by the way, what is the temperature like in Shillong? How's the weather like? I suppose it's really cold. Jia, are you telling me the temperature of Satna Center? Oh, that is the acceleration. I suppose that is acceleration. Okay, guys, 7.5 revolutions mean 7.5 into 2 pi, this much angular displacement, which is equals to 15 pi. Okay, this is your theta. Initial velocity is 2 radian per second, and what about the time? Time is 18 seconds. So what is the formula? Theta is equals to omega naught t plus half alpha t square. So theta is 15 pi. 15 pi is equals to 2 into 18 plus half alpha into 18 square. Okay. So solve it. It's really ugly equation. So let me do my best. So 15 pi. Okay. Pi का हिसाब लगाना है. So 15 into 3.14, 47.1 minus 36, 11.1. So 11.1 is equals to half alpha. 18 square is how much? 18 square, 324. So 324. All right. So 22.2 divided by 324. 0.06. Very good. Correct answer. By the way, it should be 0.068 radian per second square. Okay, clear? So I hope now you can do these questions, these types of questions. Let's do the last one and then we can proceed. Suppose a car starts from this point, all right. The car starts from this point A, starts from here, all right. Find the angular acceleration alpha, or maybe alpha is given. Okay, alpha is 4 radian per second square. Body is moving like this. This is the initial position. This is the final position, or simply I can call it B. Okay. So basically the thing is, body starts from this point, it moves anti-clockwise, angular acceleration is 4, find omega at B. Simple question. I want all of you to do this. Okay, don't do the whole calculation here. You can tell me the answer in square root and pi. Guys, you don't have to tell me the answer in decimals, just tell me the answer in pi and square root. I'll be happy. What is omega naught? 0. What is omega b? Don't know. What is alpha? 4. What is theta? The angular displacement? 3 by 2 of pi, isn't it? 3 pi by 2. So guys, the equation is omega square minus omega naught square, v square minus u square, no, is equals to 2as. That is the equation. So omega b square minus 0 is equals to 2 into 4 into theta is 3 by 2 of pi. It is equals to 12 pi. So the answer will be omega naught is equals to square root of 12 pi, which can be written as 2 root 3 pi. Just a square root of pi. Just leave it there. That is good enough. Don't have to give me the answer in the correct decimal form, and it doesn't require too much effort. Okay, is this clear? Now I hope these questions are clear to you. So let's start a new topic in this chapter, and that is the relation between linear speed or linear velocity and angular velocity. Okay. Now, by the way, we have been talking about angular velocity, and velocity is what? Angular velocity is a velocity, it is a vector quantity. So what is the direction in angular motion? How do we calculate that? It's very simple. Suppose the object is moving like this, anti-clockwise. Alright. So in order to find the direction of motion, or you can say direction of angular velocity, alright, suppose the body is moving like this. So just roll your fingers of your right hand in the sense of the motion. Alright. So roll your fingers in the anti-clockwise direction, your thumb is pointing outwards. So I will say omega's direction is outwards. Okay. In a similar way, if you talk about angular acceleration, suppose alpha is like this. Alright, alpha is like this. Then roll your fingers, the thumb is pointing inwards. So alpha is towards minus k, isn't it? Because inside we take generally as minus z direction. So guys, remember, angular velocity, angular acceleration, in fact the displacement itself, they all are vector quantities. Theta is also a vector quantity. Suppose the object starts from here and goes here. Alright. So this theta, as you can see, it is outside. So always remember, always be conscious about this, that these parameters like angular acceleration, angular velocity, angular displacement, all these things are vector quantities, and you can find the direction using your right hand. Roll your fingers in the direction specified and your thumb would point towards the direction of motion. Okay. Alright guys, now let's talk about the relation between, let me copy that whole thing, copy. Relation between linear velocity and angular velocity. Okay, very simple. So let's talk about if there is some circular motion is going on. Alright. So the body moved from A to B. Suppose the body moved from A to B, and this is the angular displacement in that motion. So if I talk about the linear distance traveled SAB, if I talk about the linear displacement traveled, it is the arc length, and arc length is equals to what? I am talking about the distance, by the way, not displacement. If I talk about the distance traveled by the particle in in linear fashion, it is a arc length AB. Okay, this is SAB. So it is equals to theta into the radius. Is it not? Arc length is what? Arc length is theta into radius. If you find the differentiation ds by dt, that will be the linear velocity, and it is equals to d theta by dt into r. R is constant. So linear velocity is equals to d theta by dt into r, which is omega into r. Does it make sense? Linear velocity is equals to omega into r. So these two quantities are linked with radius. All right. These two quantities, the linear quantities and the angular quantities, they are linked with radius. With radius being multiplied with the angular, because the same result, the similar kind of result can be obtained for acceleration as well. By linear acceleration, A is dv by dt, and that is equals to d by dt of omega into r. Again, r is constant, so acceleration is equals to alpha into r. Understood? Okay, so let's do a question. The question is, suppose there is a circular track, and on the circular track a car is moving, okay, but the linear velocity is given instead of a angular acceleration, all right, angular velocity. So linear velocity is pi by 10 meter per second. This is the linear speed of the car, and it is constant. It is constant. Okay, question is, find the number of revolutions made, the number of revolutions made in let's say 1 minute, given that the radius is 5 meters. Oh, that's quite small, 15 meters. The radius is 15 meters. So calculate the number of revolutions made in 1 minute. Very, very simple question. Anyone with the answer? So Jia says XYZ. Shillong, tell me what's your answer? What is the value of alpha here? If velocity is constant, then that would mean acceleration is constant, and the relation is acceleration is equals to r into alpha. So if a is 0, then alpha is 0. Okay. What is omega? Omega is v by r. So that is equals to pi by 10 into 15. Okay. So pi by 150. Now what is the total angle covered? Theta is equals to omega into t, because alpha is 0. The remaining term half alpha t square, this whole thing is 0. So we have theta is equals to omega, which is pi by 150 into time. Time is what? Time is 60. 1 minute is 60 seconds. Okay. So this is equals to 6 pi by 15 or 2 pi by 5. Alright. The number of revolutions made, n, is equals to theta upon 2 pi, and theta is 2 pi by 5 divided by 2 pi, pi get cancelled, so 1 by 5 or 0.2 number of revolutions. So not even one revolution would be made, it will be 0.2 revolutions. Is it clear to all of you? Yes or no? Guys, is this question clear to all of you? Okay guys, so that's it for today. We'll continue this in the next class, and we'll start the dynamics part of it as well, the forces and how these forces and velocities are dependent on each other. Okay, so thanks for coming, and please come for the next class. We'll learn something very, very interesting in circular motion. Okay, so thank you very much. Bye bye, see you, good night. Please study, please do the revision, and eat well, and have a good night's sleep. Okay, bye bye, see you.